Hello GSX, welcome, and thank you for tuning in to this presentation. I'm Manish Mehta, Chief Product Officer at Ontic. I attended GSX last September in Chicago, and I'm excited to be with you virtually today. A little bit more about Ontic. We're the first and only protective intelligence software platform purpose-built for physical security. Our goal is to enable enterprise physical security teams to get the most relevant intelligence faster for early threat detection in order to keep people, employees, facilities, and assets safe. Today, I'm going to give you a quick history of asteroids. Yes, asteroids, and how they relate to what we see today when practicing the tradecraft of protective intelligence. See more clearly. See more threats clearly. What if you had the opportunity to leverage technology to be able to see and take advantage of threats that are happening around you? You may see those threats as being a limited set today, but I'd like to widen the aperture and show you that there is a possibility to leverage technology to take advantage of much more. There is a vital and irreplaceable art form known as protective intelligence, the ability to take many data points, insights, OSINT, and be able to pull that knowledge, pull the signal from the noise, and be able to use that and leverage that to keep your principals, executives, facilities, personnel, assets safe. But what happens if you can apply science to this vital and irreplaceable art form? Could you see more clearly? Could you be able to protect more proactively? But to do this and illustrate this, let's move away from executive protection, personnel protection, asset protection, to a completely different industry and a completely different kind of protection. Planetary protection. No, not protecting the planet from global warming, but protecting the planet from these asteroids, or as the scientific community refers to them, NEOs, near-Earth objects. A large one of these, over a kilometer wide, slammed into the Earth 65 million years ago and is widely believed to have wiped out the dinosaurs. They do present a very near and very present danger to our existence, to our planet. So you would think that over the centuries, that technology must have been used and invested to be on the lookout for such an important risk and threat to our planet. The first NEO was discovered in the 1600s. And science has not really progressed over the centuries as quickly as one might think. In fact, in 1908, over the Tunguska River in Siberia, Russia, a large object, but only 150 meters wide, weighing 200 to 300 million pounds, coming in at over 300,000 miles per hour, exploded 3 miles above the Earth's surface over Siberia, Russia, a very remote location, with a force that was larger than 1,000 Hiroshima bombs. In fact, it's the largest single event recorded in human history. Over 2,000 square miles were destroyed, nearly instantaneously. 80 million trees were turned into toothpicks. You could see the glow for weeks in Europe and all the way as far as Tokyo, Japan. Yet somehow, miraculously, only 3 lives perished that day as a result of the explosion. You could say, in a way, that the Earth dodged a bullet that day. Just imagine if this object exploded over a larger metropolitan area like New York City. So you would think then that this would have woken up the scientific community and they would have invested aggressively in technology to be on the lookout for these large objects and these risks to our planet, both large and small? Well, not so much. 90 years later, another astronomer discovered a very small speck in the sky called XF11. Now, he calculated that this object was going to crash into the Earth and destroy all human existence. Now, this naturally sent a huge panic across the scientific community. Now, telescopes got a little bit stronger. The ability to look deeper into space was possible. You can now calculate and predict when an object would crash into the Earth. But as the global community started looking at this individual's calculations, they realized that he was off, thankfully, by millions of miles, and this object would come close to the Earth but would not crash into the Earth. This, nevertheless, concerned Congress, and they mandated NASA that within 10 years, they must identify 90% of these planet-killing asteroids that are over a kilometer wide. And somehow, miraculously, within 10 years, NASA was able to do this by partnering with the astronomical community globally. And they did three things, all leveraging technology. First, they leveraged technology to build a central database to house and store these near-Earth objects, these asteroids, particularly the larger ones. They invested in advanced research and intelligence gathering, built deeper, stronger telescopes, and more Doppler and other instrumentation to be able to hone in on the patterns and movement patterns of these objects. And they invested in technology to build a collaborative network of astronomers, so both professional and amateur, when they see an object in the sky, they can record it and start to pool their knowledge and insights together. And by doing this, they were able to see more clearly. Well, how much more clearly? Well, up until this period of time, in the early 2000s, it was widely believed that there were 10 objects in the sky that could destroy our planet, and about 15, maybe 17, the size of Tunguska. After building this system, leveraging technology, well, they saw more clearly. In fact, they saw and discovered 900 objects in our solar system that could destroy our planet, over 8,000 the size of Tunguska, and over 20,000 objects that could, in fact, any point, become a serious threat to our planet, or to at least a city and a town. But they wanted to leverage technology and widen the aperture further. They wanted to identify objects that maybe are harmlessly orbiting within our solar system. And could they one day become threats? What would that look like? How many objects would there be in our solar system that could easily become that threat? Well, here's what that would look like. There's 775,000 objects in our solar system alone that at any point in time could deviate from their orbit and their path and become a very serious threat to our planet. So how were they able to gather this intelligence? Well, they did some very simple things and took some very simple steps. First, they recorded the event, the object itself. Something moves in the sky. Then they identified the object's characteristics and stored it in a database. So they now had a central place to continue to hydrate information on this object, such as its location movement or how it's moved throughout the sky. They analyzed what they could about its profile and continued to hydrate new information, such as tracking risk behaviors. And they integrated additional data points from additional systems and devices, looking for patterns and changes and deviations. And anytime one of those would happen, they would trigger an alert. They would also conduct a threat assessment to understand what is that risk related to that particular object. And they would monitor those risks on an ongoing basis. And that's what they would do for NEOs. Well, interestingly enough, These are the same steps we would apply to persons of interest. We would record the individual or an event, do some research, continue to hydrate more information about an investigation, do more research, continue to add to our investigation, gather intelligence, do more research, conduct an assessment. We're just continuously hydrating our knowledge of this person of interest or person of concern. By gathering this intelligence, we become better informed to make the right decision. And this is the art form complemented by science. Leverage technology to build a more complete picture so that you can see more clearly and protect your assets. This is protective intelligence, this beautiful art form, this tradecraft, but leveraging technology. Let's shift the metaphor a bit. That large blue dot that you see, rather than that being the Earth, imagine that that's your principal. It could be a CEO's residence. It could be a corporate headquarters. It could be one of your facilities. And instead of those dots being near-Earth objects, those could be POIs, or persons of concern. Now, we can easily argue that there's a massive difference between a rock and a human. They're not quite the same, but there are some things that are. They are predictable in some ways. For example, a rock and a human both could have predictable orbits. For the POI, it could be a life event when they were laid off from their job, or they had a major change in their life that put them on a more direct path to your principle. Now, they might orbit close by, but harmlessly. But then you might have an individual that has a different trigger event or life event that puts them on a more direct path, and they become a very serious near and present danger. The beauty of leveraging technology and gathering intelligence and being able to see more clearly is to help you as early as possible, give you the information you need to help slightly deviate that individual from their path so they're no longer a direct threat. Now, we're a software company, so what we do is we provide rings of intelligence, both based on time and distance. The more time that we can give you, or the more distance we can create between that individual and your principal, the better, so that you can take the right protective actions. And as a software company, we have a software platform that cuts horizontally through these rings. Now, above these rings, we have a set of modules. Incident investigation, something happened, and you're able to record that and track that, and then conduct a deeper investigation. As you start to learn more about the individual associated with this investigation, you can conduct research and leverage investigative tools and systems to continue to hydrate information about the person of concern. As you have enough information, you might turn on intelligence to pull real-time feeds based on time and distance that gives you more sense and more place for these threats. And then you can conduct an assessment at any point in time. This is the power of having it integrated into one continuous software platform. Now, above these modules, we have tools. These tools connect to data providers, third-party tools, integrated assets and systems you may already own, or tools developed here at Ontic. So we are a platform, a software platform hosted in the cloud that houses modules and connects to tools. Below this, at the very core, we have a database that houses those persons of concern, those persons of interest. And we have analytics and metrics and insights that help you make a more informed decision. And then we can connect out to any type of device or data, from cameras to LPR systems to VMSs to your own data and data lakes, and much, much more. This is the ONTIC platform and the ONTIC solution. And another way to look at this is we help collect data and information. We help collect the dots. And then we help you connect those dots. Connect those dots perhaps to other individuals, perhaps to your assets. Again, pulling all of this noise, because we know there's a lot of information out there. But when you can connect it together, you can see a more complete picture. And we do this to help you protect by surfacing that insight and those information through our modules: incident, research, intelligence, and assessment, to help you protect, to help make nothing happen together. That is the ultimate goal. Success here is actually when nothing happens, by collecting, connecting, and protecting. Now, we're a software company, and technology continues to move forward. So it is our expectation that we will continue to invest aggressively in collecting more dots, connecting more dots, and providing more modules and tools to help you protect more principals, more personnel, more assets. So we will collect more, connect more, and protect more to make nothing happen together. That is the beauty of innovation, and we intend to be on the tip of the spear of that innovation in this space. And all for one very simple reason: to help you see more clearly. We know you have a good feel for the risks and threats that are within your known universe around the people and assets that you're trying to protect. But we believe by leveraging technology, we can help you see more clearly. Let's come full circle. In 2023, a large synoptic telescope will come online in Chile. It's been many, many years in the making. It will be the largest telescope of its kind, and it has a few functions. One is to map the known universe. After it comes online in a few short years, it will have mapped 37 billion celestial objects in the sky. It will have looked deeper and farther into our universe than any other device before it. And it also has a very, very important charter and mission, and that is to track, identify near-Earth objects, NEOs. Look how far technology has come, from the 1600s to the event at Tunguska to the late 90s, by 2008, and a few decades later. Technology continues to advance, and so will we at ONTIC. Our mission and our goal is to serve intelligence to each and every one of you whose job it is to protect, to help you see more clearly, to help take this beautiful tradecraft of protective intelligence and apply science. I hope you enjoyed learning more about the art and science of near-Earth object detection and how bringing together the right data and tools can give you a comprehensive view of threats and can prevent catastrophic events from occurring. At ONTIC, we're proud to have developed a platform focused on early threat detection and prevention. If you'd like to take a closer look at the ONTIC platform, you can go to ontic.ai/demo to request a meeting with our team. And if you have any questions for me, feel free to email me at mmehta@ontic.ai. Thanks for your time today, and stay safe.